smooth, or is it full of disruptions and innovations? I think the director of the Energy Agency this morning talked about disruptive innovation. So that's an interesting interesting way to think about it. And I'd like to point to historical examples, because I think it's interesting. And if we go back to these pictures, I found very interesting. It's the same street in New York City in the year 1900, and then just 13 years later. So in 1900, there were only horse-drawn carts on this street, and 13 years later, it was full of cars. And so this type of disruptive innovation, it's interesting to remember this, and that we're probably going to need this for the big challenges ahead. But this was, I think, changes like this were a reminder of the importance of mobility, which continues to be the case, as the previous speakers were saying. So here's another historical example I find interesting from automobile history. This is an advertisement. For those that are not reading Swedish, I can say that this is an advertisement for a car from 1936. And it says here, a car that's big about everything except for the price. But what's interesting about this ad is the fuel economy of this car, which was around 6 liters per 100 kilometers. And today it's actually not much better, and that's 90 years ago. So this, it took, and in fact, some years ago, I think it was the average in the EU was actually around 6 liters per 100 kilometers. So very slow progress on fuel economy, because this is not what the market cares about. It has cared about power, comfort, convenience. Now, so now we have to value climate stabilization and resilience. So what are the pathways? Because one thing we've learned when it comes to biofuels and bioenergy is that land use is really the key. And so it's very timely recently that the two of the 3 IPCC special reports had a big focus actually on land. First, the 1.5 report. 1.5 report pointed out some of the big issues coming up, and then the land report focused in specifically on a number of key land use issues. And if we think about the carbon cycle, actually the part we are dealing with when it comes to biofuels and bioenergy, it's not that big in terms of the numbers, but it's where we can have some impact in the future, not just through production, but also through enhancing carbon sinks in soils. We can't do so much with oceans, but eventually there as well. And in fact, that was the 3rd IPCC special report was on oceans. But so even though we're dealing with a small part of the carbon budget, there's still this land interface is only going to get more and more important for when it comes to developing biofuels markets and linking it to the broader bioeconomy. So there we go. So the IPCC 1.5 report talked about some of the co-benefits, synergies, and also the trade-offs. And I want to mention in particular that the report noted this trade-off that will come as we try to meet climate targets using land for bioenergy and for reforestation. There is a potential conflict when it comes to food security and biodiversity in particular. So how to address these trade-offs is I think going to be quite important, particularly for those two. And if we look then at some of the results from the IPCC land report, one interesting aspect of this is that the use of bioenergy and reforestation and other land-based mitigation results in quite different scenarios for land use depending on the underlying assumptions. And if you take these 3 cases, the SSPs are the shared socioeconomic pathways that are used in analyzing future scenarios. And so in the sustainability-focused scenario, there's a a reasonable amount of land used for reforestation and bioenergy, but that amount starts to increase a lot in the other two scenarios, so-called middle-of-the-road scenario and resource-intensive scenarios for the future. In here, you have the interesting result that more bioenergy is needed as the rest of the system gets less sustainable, which is a sort of ironic result in a way. And what we then, the challenge, I think, for analysts and to see where we can move positively is to find actually the creative intersection between bioenergy and biofuel pathways that are both climate smart but also positive for other goals, particularly health, but also for energy access in developing countries as well. So looking at these creative intersections maybe can help to break down this idea, which came out a little bit in the report, that, well, we're going to need bioenergy because everything is going badly, but we can also need it if it goes well. So it really depends on looking more carefully at the co-benefits. So how to think about some of these additional aspects that were included in the IPCC land report is something I wanted to mention. So in addition to climate mitigation goals and climate adaptation goals, there are also issues related to land degradation and desertification. And desertification and degradation are actually responsible for a considerable share of emissions today. And I think it was noted earlier today that in Europe, the overwhelming majority of emissions come from energy sector. Well, the opposite is the case in the developing world, where most of the emissions come from the land use sectors. So we are faced with the situation globally that we already have unsustainable land use. How can we turn it around and get, let's call it a double win out of that, to get both bioenergy, but also to improve the land use management, to avoid degradation, to avoid deforestation, because just the emissions from degradation, let alone deforestation, are quite significant. And so it's how to turn a lose-lose into a win-win. I think this is actually the question. So it's a little bit hard to see all these categories, but basically these were a way to try to show what different climate measures, what are the benefits across these categories of mitigation, adaptation, land degradation, food security. So if you look, for example, at bioenergy with BECCS, it's always a big win for mitigation, but there are concerns when it comes to adaptation and desertification and food security, because if done badly, there could be some negative consequences. But in the best practice case, the second row from the top there, you see that's where you see the green, because in the best practice case, we know it can be done well. Food security remains gray, however, simply because the net results, they're not really obvious when you run the big global models. And food security is really not an issue of the quantity of food produced. It's mainly the access to food and poverty that is the main source of food insecurity. And then the example below is for reforestation. And here the results tend to be more positive, looked at from the perspective of these integrated assessment models looking globally. But again, there is some uncertainty when it comes to food security, just because of the sheer amount of land we're talking about. It's, historically speaking, converting these very large quantities of land, hundreds of millions of hectares. This type of conversion hasn't occurred very much historically, and so the effects are perhaps still not fully understood. So I want to mention something that's not really a focus in this conference, but it relates to this general view on biomass and bioenergy, and that's the fact that the traditional uses of biomass still account for more than half of all bioenergy used globally. And these have very serious land use impacts and climate impacts. So this is what we call a lose-lose-lose. It's bad energy access, it's bad for the climate, and it's bad for land use in terms of degradation, and amounts to more than 2% of global emissions, which is almost as much as the aviation sector, in fact. So there are a lot of important measures to be taken here. In some cases, to switch to modern bioenergy, particularly in the form of biogas, in fact, which, as the speakers were pointing out earlier, is in some ways it's sort of one of the miracle bioenergy classes, just because you can get so much return, both in climate terms, but also in terms of quality of energy. So this issue of traditional biomass, I think, has to be part of the dialogue. And then question related to this when it comes to this intensive use of land is related then to food, because as we scale up biofuels and bioenergy, food security is always perhaps one of the main concerns. And an interesting aspect of this is that if you look currently at the way land is used for food, you have a very significant amount of pasture land, which only gives around 3% of dietary protein. And following the curve up here, then you see that the curve gets very steep here, because agriculture has become tremendously productive in recent decades. So we're getting actually the overwhelming majority of the food, and especially the protein requirement, from a smaller amount of land. And so it's logical, it is fairly logical in the future, that we're going to need to use some of that land for non-food production, for materials and energy. And how to do this in the best way, that's our challenge. And I think as Patricia was just noting in her talk, the great potential is particularly in Africa and Latin America. So if you look at the bars, what's above the bar here, you have a lot of considerable amount of highly suitable land for agriculture, particularly in Africa and Latin America. And this is even under conditions which are far from optimal, because we know that the yields for agriculture here are very low, so the potential is actually much higher. So land is usually not the limiting factor in these cases. It would more likely be water or social factors, but land is not really the limiting factor. It could also be sensitive areas. For example, biodiversity could be the limiting factor rather than land per se. And another interesting statistic I find with regard to this is how biomass is used for different purposes. The actual amount of biomass that goes into biofuels is very small, in fact. I think these statistics are a little bit older, but it wouldn't be much different. So you have almost 60% of biomass going to animal feed. And so if we talk about the future bioeconomy, it seems that some sort of rebalancing is needed. We shouldn't be devoting such an extraordinary amount of biomass for animal feed. It's not going to be resource efficient in the long term. So to use more biomass for the other uses is actually very logical in terms of balancing this system. So, and I think that's what we are already seeing. And then thinking about the types of crops we're going to use in the future, it's interesting to note the enormous difference in terms of soil carbon accumulation that's possible with perennial crops. And there's a lot of interesting research going on the perennial grasses. And so here there's really a great benefit in the future in terms of enhancing carbon sinks, which was one of the main points that's made in the IPCC report, that really land-based mitigation and enhancing carbon sinks is really crucial, and we cannot meet our climate targets without substantially enhancing our carbon sinks. And so to give an example that's maybe closer to the focus of this conference is with cellulosic biofuels. You can go into the analysis with the goal of avoiding competition for land, particularly when it comes to addressing food security. Negative emissions, also addressing soil fertility, and how to do this at a big enough scale that achieves climate benefits. And there are some scenarios that do suggest that if we look at this difficult to electrify sectors, which have been discussed today, aviation and heavy transport and shipping, that this is a good target to use in creating the scenarios. So integrated approaches that are enhancing sinks through carbon storage, through enhancing soil carbon in soils, and at the same time substituting fossil fuels. This is, I think, the direction things are headed in a systems perspective. Just to note also that this idea of multifunctional land use is also going to be very important when we think about land, climate, and bioeconomy. And it seemed some positive news that agroforestry has made some progress in recent years in the amount of biomass, the amount of carbon accumulated on agricultural land, a lot of it through agroforestry. And that's the green, the blue spots on the map. So to try to sort of summarize this, I think it's time, right?
It's time, yes.
Yeah. Just to point out that this is part of a transition process, you might say, where we have gone from natural economy to fossil economy to bioeconomy. And the natural economy actually was very land intensive. So subsistence agriculture and traditional biomass use, these are extremely land intensive. And with the fossil economy is the opposite, but it's unsustainable because we are relying on non-renewable resources. So in the bioeconomy, we will need quite a bit more land, but if we do it well through sustainable land management, then we, to some extent, can make this leap based on some of the principles we've been discussing today. Okay, so that's it. I do want to mention at the end we have started an initiative on the bioeconomy, which we call Governing Bioeconomy Pathways, focusing especially on these governance issues, which are so important to get things right. Okay, thank you.
Thank you, Francis. I open up the